A single explosion erased 16 kilometers of Russian defenses in less than a minute. Not by a missile, not by an airstrike, but by a drone smaller than a backpack, using Russia's own weapons against them. What followed shattered their supply lines, trapped their soldiers, and humiliated their military doctrine. The Bryansk bridge wasn't just a piece of concrete over water. It was the lifeline for an entire 16-kilometer stretch of Russian defenses. Every fuel truck, ammunition carrier, and armored convoy moving through that sector relied on it. Russia had spent months turning it into a trap, loading its underside with nearly 30 TM-62 anti-tank mines. Each mine held 7 to 8 kilograms of TNT, enough to rip open the belly of a main battle tank. The plan was simple. If Ukrainian forces tried to cross, Russian troops would detonate the mines remotely, dropping the bridge and anything on it into the Tsata River below. On paper, it was foolproof. Nets, sensors, and layered defenses were set up to block any Ukrainian sabotage attempt. But this wasn't a frontal assault. It was a precision strike from an unexpected angle. The weapon of choice? An FPV kamikaze drone, weighing just 3 to 4 kilograms, with a carbon fiber body and a nose packed with only 400 to 500 grams of explosives. That small charge wasn't enough to blow the bridge apart directly, but the Ukrainian planners weren't aiming for destruction by force. They were aiming for destruction by chain reaction. The operation began with intelligence. For a week, small, fixed-wing surveillance drones disguised as civilian craft circled the area, mapping Russian defenses. Satellite imagery revealed where the mines were buried in the bridge's support structures. Video analysis pinpointed convoy schedules and moments of low traffic. Heat maps even picked up signs of fresh excavation work where Russian engineers had planted the explosives. Electronic signals told another part of the story. Low-power RF modules were in place, ready to trigger the mines remotely. From this data, the Ukrainian team identified a weak point: the northwestern support leg of the bridge. It held at least 2 mines close enough together that if one detonated, the other would follow. That was the target. The FPV drone's approach was a masterclass in stealth. With a small infrared signature, a quiet electric motor, and a flight profile hugging the terrain, it slipped past Russian thermal cameras and sensors. At 120 kilometers per hour, it gave Russian operators only 2 or 3 seconds to spot and react. By the time they could have fired an anti-drone cannon or activated a jammer, it was too late. The pilot guided it manually until the final seconds. Then, semi-autonomous systems took over. Using LiDAR and optical matching, the drone locked onto the exact underside point of the bridge girder. 10 seconds before impact, it dipped low, then climbed sharply, smashing into the steel console where the mines were mounted. The small explosive charge was just enough to trigger 1 TM-62 mine, and that's all it took. The first mine went off, setting off the others in rapid succession. Within moments, nearly 250 kilograms of TNT erupted. The blast hurled steel beams and concrete slabs into the air, tearing the bridge in half. A shockwave ripped through the valley, flattening vegetation and leaving craters in a 100-meter radius. For the Russian army, this wasn't just a loss of infrastructure. It was a collapse of their defensive architecture. Supply routes were gone. Evacuation corridors were severed. Units on the far side of the river were suddenly cut off from fuel, ammunition, and reinforcements. But the deeper humiliation lay in the fact that their own mines had done the damage. A trap meant to stop the enemy had become the weapon that stopped them. And for the Ukrainian side, the cost was minimal. A single drone worth a fraction of one artillery shell had crippled an entire sector. The Tsata River Bridge wasn't just another crossing. It was the backbone of Russia's supply chain in Bryansk. Every day, it carried roughly 300 tons of fuel, ammunition, and equipment to forces guarding a 16-kilometer stretch of the border. When it fell, that flow stopped almost instantly. Within 48 hours, fuel deliveries had collapsed to near zero. Artillery batteries went quiet, and armored units sat idle, unable to move. This collapse hit the heart of Russia's buffer corridor doctrine, a defensive strategy built on minefields, anti-tank trenches, and layered checkpoints designed to slow Ukraine before reaching Russian soil. Bridges like Tsata's were the arteries keeping this system alive. Without them, the doctrine crumbled. The Ukrainian strike worked because it exploited the enemy's blind spots. The FPV kamikaze drone was small, fast, and almost invisible to the Russian detection systems guarding the bridge. Surveillance towers and thermal cameras were tuned to track vehicles and helicopters, not a carbon fiber craft with a heat signature smaller than a bird. And because the drone used a fiber optic control link, it couldn't be jammed by standard radio frequency interference. Even if spotted, Russian operators had only a 2 to 3 second window to respond as the drone closed in at 120 km per hour. The area wasn't protected by high-speed anti-drone cannons like the Pantsir S-1. Those systems were stationed far to the rear, guarding radar installations and command centers. At Tsata, defenses were almost entirely passive. Mines, obstacles, and small arms patrols. None of it could stop what was coming. When the FPV slammed into the bridge's northwestern support leg, it triggered one TM-62 mine, setting off the rest. Nearly 250 kilograms of TNT detonated in a chain reaction, hurling concrete and steel into the air. In seconds, the bridge was gone, and so was Russia's most vital supply line in the sector. For Ukraine, this was a textbook demonstration of deep strike logistics disruption. A 3-layer strategy. Number 1. Cheap drone swarms to overwhelm defenses. Number 2. Precision strikes on high-value infrastructure. Number 3. Electronic warfare to blind detection systems. In Bryansk, all 3 layers were present. Decoy drones earlier in the week may have distracted defenses. Jamming likely concealed the FPV drone's approach. And precise targeting of the weakest structural point made sure the smallest charge caused the biggest damage. The operational impact was clear. Units trapped without fuel or ammo began abandoning positions. BMP-3 vehicles couldn't maintain fire support. Artillery units were reduced to small arms defense. The alternative resupply routes, through Klintsy or Starodub, were longer, slower, and exposed, both having been attacked in the past. What Russia faced was more than a tactical setback. It was a choke point kill. A $5,000 to $25,000 drone had erased millions in fortifications and crippled a defensive sector designed to last years. Now, Moscow had a choice: rebuild with even heavier mine-based defenses, risking another catastrophic backfire, or pull back and surrender ground. The destruction of the Tsata bridge was more than a battlefield success. It was a political embarrassment for the Kremlin. For years, Russian leaders showcased their air defense systems like the S-400, Pantsir, and Tor M2 as impenetrable shields. These platforms were paraded through Red Square, symbols of a military that claimed absolute control of its skies. Yet, in Bryansk, a drone costing less than a family car slipped through that shield and used Russia's own mines to detonate a vital crossing. This hit harder than the physical loss. In military engineering, a static defense, minefields, trenches, fortified choke points, is meant to buy time. But if it lacks flexibility, it becomes a liability. That lesson is now written into Bryansk's smoking ruins. Either Russia reduces its reliance on fixed explosives, opening corridors for Ukrainian advances, or it invests in heavier, more complex mine bridge systems, which will be slower to build and far more costly. The economic damage is already significant. Repairing the bridge alone will cost millions. Factor in delayed fuel shipments, immobilized armored units, and the cost of diverting convoys along longer, more vulnerable routes, and the bill climbs sharply. And the timing couldn't be worse for Moscow. On the same week, oil depots in Sochi burned, a tanker station in Volgograd was struck, and a fuel train exploded on the Rostov-Salsk line. The bridge attack wasn't just a hit. It was part of a broader squeeze on Russia's war machine. Behind the scenes, Ukrainian drone technology is advancing faster than Russia can adapt. Semi-autonomous FPV software now allows a drone to be manually guided until its final approach, where onboard sensors and AI take over. In the last 15 meters, LiDAR and optical matching pinpoint the weakest structural spot, correcting for wind or interference. This makes the hit almost inevitable, even under pressure. For Russia, countering this requires more than propaganda. Hard-kill defenses like cannons or lasers need to be in place, ready to fire in seconds. But cannon systems like Pantsir struggle to hit such small, fast targets at close range, and high-energy lasers are still experimental. That gap leaves a window of vulnerability, one Ukraine has learned to exploit repeatedly. Now, the question isn't just how Russia will rebuild the Bryansk bridge, but where Ukraine will strike next. If a cheap drone can erase a fortified crossing in minutes, what happens when the target isn't a bridge in a border region, but a critical supply hub deep inside Russia? Because if the Kremlin's mines can destroy its own defenses, what else might collapse from the inside before the enemy even arrives?